Hi, my name's William Dang. So, the world around us is filled with appearances that are periodic in neutral. Periodic behavior can be modeled by sinusoidal function. Every periodic can be expressed as an algebraic combination of sine and cosine curves. Derivative of sinusoidal function. The topic what I'm going to talk about can be used to solve this problem. So at the end of this video, you will determine the first derivative of a sinusoidal function. Solve problems using the product, chain, power, and quotient rules. Solve problems arising from real-world application. So first, we are going to calculate the I-rod of sinusoidal function. I will try to determine the I-rod at s equal to 0 or the function fs equal to sine x. So according to the calculator, we can note that sine 0 is equal to 0 and cosine 0.0001 is approach to 1 and sine 0.0001 is approach to 0.0001. F pi 0 is equal to 1. We know the first derivative of f0 is equal to 1. So this method can be used to calculate the first derivative of fs equal to sine x and fs equal to cosine x. So we can see that the derivative of sine x is equal to cosine x, and the derivative of cosine x is equal to negative sine x. So consider the following functions. How to calculate the derivative of these functions? So the chain, power, product, and chain rules can be used to determine these kinds of questions. I will use 4 examples to explain these rules. So the formula of chain rule is y equal to fgs, and the derivative of y is equal to the derivative of fgx times the derivative of gx. So for the power rule, y is equal to x to the power of n, and the derivative of y is equal to ns to the power of n minus 1. Two times sine x and times the derivative of sine x, which is cosine x. So it's equal to 2 sine x cosine x. So y equal to fxgs, and his derivative is the derivative of fx times gs plus fs times the derivative of gx. So let a equal to t squared and b is equal to cosine t. Then the derivative of a is equal to 2t, and the derivative of b is equal to negative sine t. So put them into the formula. So this is the formula of y and the derivative of y. So y is equal to tangent x, and we know tangent is equal to sine x divided by cosine x. So the derivative of tangent x is equal to so these rules can calculate the first derivative of secant, cosecant, and cotangent functions. Last, I'm going to use an example to demonstrate how an sinusoidal function be used to solve the real-world application. So from the question, we already know the position x equal to 2 cosine 3t and y is equal to cosine 2t. So the velocity is equal to the first derivative of the position. So when the position doesn't move, the derivative of this point is zeroed. It also means the instantaneous velocity is equal to 0. So we can calculate the velocity x and the velocity of y. So Vx is equal to the derivative of x and Vy is equal to the derivative of y is equal to dy divided by dt is equal to negative 2 sine 2t. And we know the time is 4.1 seconds, and then we put into the Vx and Vy, so we can calculate Vx is equal to negative 6 sine 3 times 4.1 seconds is equal to 1.579 meter per second, centimeters per second, and Vy is equal to negative 2 sine 2 times 4.17 is equal to negative 1.88 centimeter per second. So that we can calculate the V. So V is equal to Vx squared plus Vy squared, then to the power of 1 over 2. So it's equal to 2.46 centimeters per second. And then we need to calculate the direction. And theta is equal to 1.88 divided by 1.579, which is equal to 50 degrees. But we can note that Vx is positive and Vy is negative, so it is in the fourth cojet. So the angle is equal to 360 degrees minus 50 is equal to 310. So the velocity of the two is 2.46, and the direction is, and it is south 40 degree east.